This video, we're going to talk about 1.2 Objective 1, where we answer conceptual questions involving representing functions. So give 4 ways in which functions can be defined and represented. A graph works, words, a formula, or a table. An expression is not necessarily a function. So it doesn't have an equal sign in it, so it can't be a function if it's an expression. What is the domain of a polynomial? The domain of a polynomial is the set of all real numbers. That's A. What is the domain of a rational function? The domain of a rational function is the set of all real numbers, except those for which the denominator is 0. That's D. Number 4. What is a piecewise linear function? A piecewise linear function is a function that has linear definitions on each part of the domain. So that's A. If you have the graph of y equals f of x, how do you obtain the graph of y equals f of, and then in parentheses, x plus 16? You would shift the graph 16 units to the left. That's B. How do you obtain the graph of y equals f of 3x from the graph of y equals f of x? You would horizontally compress the graph of f of x by a factor of 1/3. That's A. Given the graph of y equals x squared, how do you obtain the graph of y equals 4 times x plus 5 squared plus 9? So you would shift the graph to the left 5 units, then stretch the graph vertically by a factor of 4, and then shift the graph 9 units up. That's B. Number 8, determine whether the following statements are true and give explanations or counterexamples. So A says all polynomials are rational functions, but not all rational functions are polynomials. The statement is true because a polynomial function p of x can be expressed as f of x equals p of x over 1, making it a rational function because q of x equals 1 is a polynomial function. However, since rational functions are of the form p of x over q of x, where p and q are polynomials, not all rational functions are polynomial functions. For example, f of x equals x plus 1 over x is a rational function, but is not a polynomial function. B asks, if f is a linear polynomial, then f of f is a quadratic polynomial. That is false. So for example, let f of x be x plus 2. f of x is going to be x plus 2 is x plus 4, which is a linear function. So that's C. Part C, if f and g are polynomials, then the degree of f of g and g of f are equal. So the statement is true. Let f of x be equal a to the n, x to the n plus a to the n minus 1, x to the n minus 1 plus dot 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 plus a1 x1 plus a0, a degree n polynomial, and g of x equal b sub m, x to the m plus b sub m minus 1, x to the m minus 1 plus dot 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 plus b sub 1 x plus b sub 0, a degree m polynomial. The first term of f times g is an bm to the m x to the n times m, and the first degree, or the first term of g of f of x is b sub m a sub n to the m, x to the m plus n, m times n, and because multiplication is commutative there, then they're going to have the same degree. They'll have different coefficients, but they'll have different degrees because the degree of f of g of x is n times m, and that's equal to the degree of g of f, which is m times m. So that's b. Long explanation there, but that's important to know that they have to be the same degree when you compose them either way. If you get different degrees for them, then you made a mistake. And then for part D, let's look at the question up here. Asks us to graph g of x equals f of x plus 2. Shift the graph of f 2 units to the right. No, that's wrong. We need to shift 2 units to the left. The graph of y equals f of x minus b is the graph of f of x shifted horizontally b units to the right if b is greater than 0, and left if b is less than 0. Since b equals -2 is less than 0, the graph is shifted to the left. All right, that's it for this video. We'll come back next time and talk about 1.2 objective 2. See you for the next video.